Okay, same paper. This is February, March 2022, paper 1-2. Look at the question number 31. In the circuit shown, the lamp P is rated to 50 volt and 50 watt power. And the lamp Q is rated to 50 volt and 200 watt. The two lamps are connected in series to a 250 volt power supply. And the question is, assume that the resistance of each lamp remains constant. Which statement most accurately describe what happens when the switch is closed? Look, from this voltage and the power, we can calculate the resistance of the lamp. For example, we take this as first P. Power is equal to V squared by R, and the R is equal to V squared over power. So the voltage for this is 250 and its power is 50. So 250 squared divided by 50. So 1250, 1250 is the resistance of the P. Similarly, we can calculate the resistance of this Q. The resistance of the Q is its voltage square, 250 square over 200, this power. Answer is coming 312.5. Now, when we will calculate the ratio between their resistors, this is 4 times bigger than this. It means the resistance of the P is 4 times more. Now, both are connected in series. Here it's quoted, it's mentioned here. So in series, current remains same. So current same. So power is equal to I square R. When the current is same in series, so power totally depends on the resistance. Mean the power directly proportional to R. It means the power of the P is 4 times more than the power of this Q, because the ratio between the resistances is 4:1. So according to this relation, the power ratio is same. So it means the power of P is 4 times more as compared to the power of the Q. That's why the answer is A. Lamp P emits 4 times as much power as the lamp Q. So here, P directly proportional to R. So this is question number 31. Move to question number 32. A piece of the wire has a length of 0.8 meter and a diameter of 5.0 into 10 power minus 4. The current and voltage characteristics of the wire is shown. Mean the graph between I and V is given. What is the resistivity? Look, resistance is equal to rho L over A. And resistivity rho is equal to RA over L. From this graph, we can calculate the resistance. Resistance is equal to V over I. So the maximum voltage is 10 and the maximum current is 5. So 10 divided by 5, the resistance is 2 ohm. Now we substitute the values. Resistance is 2. Area of the wire will be pi by 4 diameter square. The diameter is given here, 5 in 10 power minus 4 square. And the length is also given, it is 0.4. So 2 times pi divided by 4 times 5 in 10 power minus 4 square divided by 0.8, you will get this answer. And C is the correct value then. So this is 32. Now move to 33. 10 cells, each of EMF 1.5 are connected together as shown. Look, this first positive this side, second positive same side, third same side, same, and up to this number, mean 9 cells are connected in series. Their negative is connected with the positive. So all are throwing the voltage in one direction, mean they are connected as their positive side is towards the left. But look at this 10th one. Its positive is connected this side. So it's a negative cell. So according to the Kirchhoff's second law, so these 9 cells are throwing voltage in this direction. So 9 times 1.5. But one cell is throwing voltage in this direction. So 1 times 1.5 is opposite direction. So 9 minus 1 mean 8 cells are delivering the resultant potential, resultant EMF So 8 times 1.5, the answer is 12. Or 1.5 multiplied by 9 minus 1.5, you will get the same answer. So one cell is connected in the opposite direction. So one cell is canceling the EMF of other cell. So how many cells are left? 8. So 8 multiplied by 1.5, 12. So this answer, 12. Now this 34. A cell of the EMF, E capital, and internal resistance R is connected to the variable resistor. This is the internal resistance, and this is the external resistance. The resistance of the variable resistor is gradually R to 3R, mean this variable resistance changes from R to 3R. Which graph shows the variation of the potential difference across the internal resistance with the PD across the variable resistor? Okay, according to Kirchhoff's second law, EMF is equal to I, sum of the resistors. This is internal, this is external. So I into small r is actually the voltage across this internal resistance, which is represented by the small v. And I times capital R is the voltage potential difference across this resistor, which is represented by capital V. But look at the graph. All graphs are drawn for small v against capital V. So we will make small v subject of the equation. So it becomes V is equal to E minus capital V, mean V small is equal to minus 1 time capital V this. So when capital V is plotted at the x-axis, and the small v plotted at the y-axis. So this minus 1 is the gradient. It means the gradient of the graph is negative. So look at these 4 graphs. This gradient is positive. So B is not the correct option. D, gradient positive. So we will eliminate B and D. Now 2 graphs are left, A and B, where the gradient is negative. Now look, initially, the external resistance is equal to R, small r. Small r, the resistance of internal resistance also. So we can write here EMF is equal to IR plus IR. So it means the EMF is actually equally divided between these 2 resistors. So here the small v is 0.5 EMF, and this capital V is 0.5 EMF. So when the small resistance, when this resistance external is equal to the small r, so both resistance are having the same potential, and that is the half of the EMF. So definitely this is the point. So small v is a half of EMF, and the large V, half of the EMF. Similarly here. Now next, we have to increase the resistance from R to 3R. So this is a fixed resistor, and this is now 3R. So both resistors are connected in series. In series, the potential directly proportional to resistor, this is the potential divider formula. So definitely this capital V increases due to large resistance, 3R. When this resistance is 3R, its voltage is large, then definitely the voltage, the potential across small r, means across this internal resistance decreases. It means when the resistance of this variable resistor increases, capital V increases and the small v decreases. That's why is the graph, because when V is increasing, the small v is decreasing. So this is not the option, because we have to increase the capital R, mean the variable resistor, from R to 3R. And in this graph, the resistance of the external resistance is decreasing because the graph is plotted for this region. So this is wrong. So we have to take this answer A. Next, very easy. Each of the Kirchhoff 2 laws presumes that some quantity is conserved Which row states the Kirchhoff first law? Very simple. Sum of currents entering the junction is equal to sum of the currents leaving the junction. And the quantity which is conserved is the charge for the first law of the Kirchhoff. So A is the answer. Simple one. Now move to the 36. A cell has an EMF of 8 volt. An internal resistance is negligible. The cell forms the part of the circuit. The reading of V1 and V2 both are 4. It means this voltage 4 volt, this is 4. So it means the voltage across this and the voltage across this combination is same. It means, so the resistance is also same. Look here, these two resistors are connected in parallel. 4 ohm mean the net resistance is 2. When voltage is same, then the net resistance will be same. If here 2 ohm net resistance, so definitely 2 ohm across it. That's why this 8 volt is equally divided between these two combination. If 4 volt here, 4 volt here, the same resistance. So this total resistance is 2 ohm. So this resistance must be 2 ohm. That's why the answer is B. Now move to this 37. In a circuit shown, the cell has negligible internal resistance and reading on the galvanometer is 0. So if the reading is 0 here, it means that no current is passing through because same potential at the both ends. Same potential at the both ends. That's why no potential difference, no current is flowing. So galvanometer reading is 0. Now this is a 4 volt. The ratio between these two resistors, 3 and 9, is 3:1. So according to potential divided formula, voltage and resistance both are divided in similar ratio. So 3:1. So the voltage 4 is also divided in the same ratio. So 3 volt here, 1 volt here. If this is the 3 volt, suppose here must be a 3 volt. 3 potential, 3 volt potential, because the reading of the galvanometer is 0. So it means 3 volt here and 3 volt here. That's why the galvanometer is 0. No potential difference. No potential difference. No current is flowing. Galvanometer reading 0. So here potential 3 volt. Here potential 3 volt. Now look at this. This is the 9 volt. And this 9 volt is divided between these two resistors here. Now these two resistors are dividing, are sharing the voltage. If 3 here, then definitely 6 here to get the 9. 3 plus 6 becomes 9. It means the voltage here is double. That's why the resistance of this unknown resistor must be double of the 6 ohm. So it's 12. That's why the answer is C. Now move to the next one. When alpha particles are directed at gold leaf, number one, almost all alpha particles pass through without deflection. It means most part of the atom is empty space. Only the central part is dense, which is called the nucleus. So here look and see, the gold nucleus is very small. So most of the alpha particle miss all the nuclei. I mean, the central part is very small and it's dense. And the number two is a few alpha particles are deviated through the large angle. So the alpha particle are particles which are going to hit almost center of the nucleus. They are deflected at the large angle. So occasionally the path of the alpha particle is close to the nucleus. Definitely when the path of the alpha particle is very close to the nucleus, both are positively charged. So there will be large repulsion and large angle of the deflection. So C is the option here, correct option. Next, a nucleus X is a radioactive and decay into a nucleus Y. X and Y are isotope of the same element. So isotope mean they have same number of the protons. So suppose the proton numbers are Z, then the proton numbers for the Y is also Z. Which combination of the particle could have been emitted during the decay process? 1 alpha and 1 beta. Suppose X is emitting 1 alpha. So 1 alpha emitted, 2 proton decreases, then 1 beta, 1 proton increases. So Z minus 2 plus 1, this is Z minus 1. It's not Z. So A is the wrong option, because the proton number for the Y must be the same as that in X. The answer must be Z after emission of alpha and beta. Now come to the B option, 1 alpha and 2 beta. So Z minus 2 because 1 alpha and 2 beta mean plus 1 plus 1. So plus 2 minus 2 cancelled. So look, the answer is again Z. It means the B is the correct option. After the emission of alpha, 1 alpha and 2 beta, the proton number remains same. That's why B is the option. And you can check similarly C and D. So B is the correct option. Now the last part, last question. A positively charged meson consists of a quark and anti-quark. A positively charged meson mean it has plus E elementary charge. What could be the quark and the anti-quark? A option, charm plus 2 by 3 elementary, anti-quark minus 2 by 3 elementary. When both are added, answer becomes 0. No, it's not the correct option, because the answer required is plus 1E, not 0. B, minus 1 by 3 and minus 2 by 3, when added, the answer becomes a minus 1 elementary. No, this is positively charged, not the negatively charged. Move to the C, minus 1 by 3 elementary for the strange, and for the anti-bottom, plus 1 by 3. So answer becomes 0. No, it's not neutral. It is positively charged. So when we will look at D, up is plus 2 by 3 elementary, anti-strange is plus 1 by 3 elementary. So up and anti-strange plus 2 by 3 and plus 1 by 3. After calculation, you will get this answer. Hence, the correct option is D.